Let's find the error in problem number 1. Again, our most common incorrect answer was A. What do we think people were thinking when they did A? We have 2 times the quantity of B plus 3 plus 4. Okay? And in the end, the answer for A was 2B plus 7. My guess is what people did was they distributed the 2 and got 2B. Then they added the 3 plus 4, which is 7. Okay? When in actuality, what they should have done, write it again, was we need to distribute. I have 2 of B plus 3. So I have 2 times B, which is 2B, 2 times 3, which is 6, now plus 4. And now I combine my like terms, which is 6 plus 4, to get 2B plus 10. Let's take a look at problem number 2. Which algebraic statement represents the following expression? And here is our expression. The correct answer is C. 7 plus 6 times the sum of 8 and a number. The most common wrong answer was 7 plus 6 times 8 plus a number. If I were to translate A, 7 plus 6 times 8, 6 times 8 plus a number, and we'll call that number n. Okay? By having in the word the sum of, okay, that means I'm going to be putting parentheses around it. So the sum of 8 and a number. And that's what we have here. We have the parentheses, so it holds the fact that I need the sum of 8 plus a number. Problem number 3. Faith makes greeting cards with colored paper. She plans to make 1/5 of the cards out of red paper. She has 25 sheets of colored paper in all. If she uses all the colored paper she has, how many sheets are a color other than red? So first, 1/5 of the cards. So 1/5 of the cards. Well, what number represents the cards? She has 25 sheets. So 1/5 of 25. And when we write this, it's part of a whole, which means multiplication. Okay, and then we multiply across. We get 25 over 5, which equals 5. That means, okay, remember, 1/5 of the cards are red. So 1/5, so 5 are red. But the question says, how many sheets are a color other than red? So if we 25 total, 25 minus 5 gives us 20, and our answer is B. Which of these expressions are equivalent to P over 3? Select each correct answer. Now remember, we've talked about that this means division. So another way of writing this is P divided by 3. Is there any of those there? No, there is not any of P divided by 3. One method is to plug in a value. So maybe I'm going to say P equals 6. So now I'm going to go through each of these. Okay, so if I have up here P equal to 6, 6 divided by 3 is 2. So I'm looking for things that have a value of 2 when P equals 6. So A, let's start with A. Does 6 minus 2/3 times 6? So let's look here, multiplication first. Okay, 2/3, okay, of 6 is 4. So therefore, this equals 6 minus 4, which is 2. B, 1/3 P, which means 1/3 times 6. Okay, multiply my numerators, I get 6 over 3, which is also 2. C, if P is 6 minus 3 is 3. D, 3 divided by 3 divided by 6. P is 6. Okay, that's going to be 1/2. E, 3 times 6 divided by 9. So we have 18 divided by 9, which is 2. And then F, 1/3 times 6 plus 1/3 times 6 plus 1/3 times 6, which equals 2. 1/3 of 6 is 2. So 2 plus 2 plus 2, that will equal 6. So C does not equal, D does not equal 2, and F does not equal 2. So our answers are going to be A, B, and E. Which expressions are equivalent to 6 plus 12x? Select each equivalent expression. Okay? There's two ways of doing this. Let's first use the distributive property. Okay? Here, 3 times 2 is 6. 3 times 4x is 12x. Okay, so we have 6 plus 12x. That one's good. Here, 3 times 2, once again, is 6. 3 times 6x, okay, is 18x plus 2x. When I combine my like terms, I'm going to get 6 plus 20x. So therefore, this is not equal. Okay? 5 times 1 is 5. 5 times 2x is 10x. Okay, plus 1 plus 2x. Let's combine like terms. I have a 5 and a 1, which is 6. 10x plus 2x gives me 12x. That one's good. 7, and then 7 times 2 is 14x minus 2x minus 1. Once again, let's combine like terms. 7 minus 1, remember that sign comes with it, equals 6. 14x minus 2x gives me 12x. So this one is also equal. Finally, 7x, oops, sorry, not x. 7 times 1 is 7. 7 times 2x is 14x plus 2x minus 1. 7 minus 1 is 6x, but 14 plus 2x will give me 16x. So this is a no. So the ones that are equal are A, C, and D. The other way of doing this would have been like the previous problem, where I choose a value for x and then substitute it in. The area of Melanie's bedroom floor is 1.5 times the area of her kitchen floor. The area of her kitchen floor is K. Select each of the following that represents the area of Melanie's bedroom. So again, I'm doing 1.5 times the area of the kitchen floor. So we're using K for the area of the kitchen floor. So I am multiplying it by this. So right away, the first one is true. Remember, it said each of the following that represents. So there probably is going to be more than one answer. Well, here, I can't, when I add, they're different terms, so I cannot, they're unlike terms, so I can't combine them. Same thing here. When I add these, this is a K and this is not a K, so I take that out of the mix. Both of these now are like terms, K plus 0.5K. When I have a variable, it is assumed that I have the number 1. So I have 1K plus 0.5K, so that's going to give me 1.5K, which is what I'm looking for. Check. Here, okay, at first glance it looks good, but remember this is a 1. So 1 plus 1.5, this gives me 2.5K. So that is not my answer. Which expressions are equivalent to 6 plus 5 times the quantity of x plus h? the most efficient way, again, is to use our distributive property. So I'm going to distribute my 5 to the x, which I get 5x. Then I distribute the 5 to the h, which I get plus 5h. I had 6h there. So when I combine my like terms, my h's, I get 11h plus 5x. So this one, nope. Sorry, that was a plus sign over there. That's a no. 11h plus 5x, yep. Okay, 12h plus x, no. 6h plus 5x plus 5h. Well, that's what I had here. That's a plus sign over here, not a t. Okay, so that's a good one. Okay, and then this one I have to double check. I need to distribute that 6h. 6 times 5, that's giving me 30x. I don't even need to continue, but again, plus 30h. So therefore, B and D are the correct answer. All right, for this one, it wants to know, are the expressions shown equivalent? Show or explain all of the steps you use to determine your answer. Use properties of operations to justify each step. So I'm going to go over 2 ways. So here is expression 1, and here is expression 2. I'm going to first use my distributive property. So I multiply. 5 times 2 is 10, and there's an x attached. 5 times 3 is 15, and there's a y attached. They are 2 different variables, so I cannot simplify any further. Expression 2, 3x plus 6y plus x plus 3 times sum of 2x plus 3y. So again, I need to use my distributive property here. That becomes 3 times 2 is 6, and there's an x attached. 3 times 3 is 9, and there's a y attached. Then I'm going to go back and rewrite so I do not forget. Now I combine like terms. I have an x, I have a plus x, and I have another plus x. So 3 plus 1 plus 6, that is going to give me 10x. 6y plus 9y is going to give me 15y. These two are the same, so therefore, yes, the expressions are the same. The other one is to give a value. I might say x is 2 and y is 3. So then I substitute my values. 5 times 2 times 2 plus 3 times 3. Okay, to go by order of operations in my parentheses first. Okay, 4 plus 9 is 13. So then I'm doing 5 times 13, which is 65. Then here I have 3 times 2 plus 6 times 3 plus 2 plus 3 times the quantity of 2 times 2 plus 3 times 3. Yes, it's a long process. According to order of operations, I do what's in my parentheses first. So I have 3 times 2 plus 6 times 3 plus 2 plus 3 times 4 plus 9. Okay, then I would simplify, and I'm going to get 6 plus 18 plus 2 plus 3 times 13. Okay, 6. Let's do this. 3 times 13 is 39. So I get 6 plus 18 plus 2 plus 39, which also equals 65. They are equal to each other. Okay, there's no way around it. Sometimes problems just take a lot of organized computations. Brianna's teacher asks her which of the 3 expressions are equivalent to each other. Brianna says that all 3 expressions are equivalent because the value of each one is -4 when x equals 0. Brianna's thinking is incorrect. They are saying she is incorrect. Identify the error in her thinking, determine which of the 3 expressions are equivalent, and explain or show your process. Okay? when we substitute, it is best not to use 0. So that's the first part. And we want to check with another number. Okay? So we could substitute another number in. But let's first by looking at combining like terms. If I have 9x minus 3x, that gives me 6x minus 4. Okay, then here we have 12x minus 4. And then here, again, if we combine like terms, we get 6x minus 4. So that could be one of your explanations. Okay, if you're combining like terms, okay, these two, expression A and C, are equivalent. Okay. The other thing is we want to then, we could choose another value for x. Okay, maybe if we choose x equals 2, then we're going to substitute in 9 times 2 minus 3 times 2 minus 4. We get 18 minus 6 minus 4, okay, which will be 8. Okay. Then for the next one, we're going to do 12 times 2 minus 4. 24 minus 4 is 20. And then finally, we're going to do 5 times 2 plus 2 minus 4. 10 plus 2 minus 4, 12 minus 4 is 8. So again, this proves what we did here, okay, algebraically. This proves it mathematically. Use the replacement set 4, 6, and 12 to find which values will make the equation 2x plus 4 equals 16x minus x true. The correct answer is D. The most common wrong answer was B. Now, when we have a replacement set, that means that these are the values of x. I believe the reason the common wrong answer was B was because when we rewrote or when we saw this problem, we did not plug in to both sides of the equation. There is an x over here. The reason I think that's true is if we take the most common wrong answer and put 2 times 6 plus 4 equals 16, 2 times 6 is 12 plus 4 is 16. People forgot to substitute for this side of the equation. So therefore, what it should be is 2 times 6 plus 4 equals 16 minus 6. Now we'll see that this side of the equation is 16, but this side of the equation is 10, and that is why answer B does not work. When we put 4 in for x, we get 2 times 4 plus 4 equals 16 minus 4. 2 times 4 is 8, plus 4 is 12, so this simplifies to 12. And this side, 16 minus 4 is 12. Now both sides are true and equal. So when you're looking at this, make sure, okay, you're looking at the whole equation. The variable x represents a value of the set 4, 6, 7, 8. Which of the values of x makes 2 times the difference of x minus 4 plus 3 equals 7 a true statement? So all we're doing now is just plugging in plus 3 and seeing if this is a true statement. 4 minus 4 is 0, so anything times 0 is 0, so 0 plus 3 is 3, so this 3 does not equal 7, so this is out. 2 times 6 minus 4 plus 3 equals 7. 6 minus 4 is 2. Okay, and then 2 times 2 is 4. 4 plus 3 is 7. Okay, so this one checks out. I always want to, just in case, go through just to make sure that maybe I didn't make a mistake. 7 minus 3 is 4. 4 times 2 is 8. 8 plus 3, more. Okay, then here it would have been 8 minus 3 is 5. 5 times 2 is 10, plus 3, which would give us 13. So these are definitely out, and B is my correct answer. Okay, which number in the set 6, 12, 18, 36 satisfied the equation 3x minus 9 equals 27? So once again, I'm just substituting and solving. and seeing if it's a true statement. Okay, 3 times 6 is 18, and I'm subtracting a number, so that's definitely a no. 3 times 12 is 36. 36 minus 9 is 27, so that is our correct answer. Which of the following given values will make the inequality n minus 93 is greater than 175 true? Okay, so if I solve this just to find out what n has to equal, okay, we are going to do the inverse operation. So I'm going to add 93. So when I add 93 to 175, I get 268. So n has to be greater than 268. So then I'm going to go through. This is a no. A is a no. B is a no. It has to be greater. This is saying equals 268. I cannot have that because 268 minus 93 is 175, and 175 is not greater than 175. So it has to be two that are larger. The other way of doing it is, again, substituting in. Does 82 minus 93, is that greater than 175? No, we already know that's going to be a negative number. Is 105 minus 93 greater than 175? No, because I'm subtracting out. Is 268 minus 93 greater than 175? We said that that equals 175, so 175 cannot be greater than 175. Okay? Anything greater than that 268 will be that answer. Let x represent any number in the set of even integers greater than 1. Any even numbers in a set of even integers greater than 1. X is less than 0. Nope, we're going into the negatives. X is greater than 0. No, because if I have a number, I could have a number greater than 0 as 1. Okay, and 1, okay, is not even. Okay. Next, x is less than 4. No, because I'm going to be going into the negatives. X is greater than 4. Okay, this is my correct answer. X is greater than 4. Because again, right here it says greater than 1.
Could you please call?
Drag and drop 3 values into the space provided that will make the inequality 18 minus 3x is less than 10 true. This is written very poorly because the 18 is over all the way over here to the right. So it is 18 minus 3x is less than 10. So again, all we're going to do is substitute our values in. So if I have 18 minus 3 times 1.3 is less than 10. Okay, it becomes 18 minus 3.9, and 14 is not less than 10. So that is out. Next one, 18 minus 3 times 2 is less than 10. 18 minus 6, okay, is 12, which is not less than 10. So that one is out. Okay, next one, 18 minus 3 times 2.7 is less than 10. 18, 3 times 2.7 is 8.1, is less than 10. And is 9.9 less than 10? Yes, it is. Okay, so that one would be dragged, so that is a good one. Okay, then I'm going to come over here, and we have 18 minus 3 times 2.5 is less than 10. 18 minus 7.5 is less than 10. This becomes 10.5 is not less than 10. Okay, and then finally, 18 minus 3 times 6, is that less than 10? 18 minus 18 is 0. and 0 is less than 10. So this one, okay, and is true. Nope, that's not right. Do that.